Sometimes you have to do something just to show that you can do it. When the Wright brothers flew for the first time, they flew an experimental aircraft. And in the same way, the Mars helicopter is designed to show that we can fly powered helicopter flight in the Martian atmosphere.
From day one, this was the unwavering dream of our team, to get our helicopter launched to Mars so that we can get that opportunity to do the very first rotorcraft flight test in the actual environment of Mars. It's extremely difficult to fly at Mars because the atmosphere is so thin. Compared to Earth, at Mars it's less than 1%. So the first and foremost challenge is to make a vehicle that's light enough to be lifted. And then the second is to generate lift. The rotor system has just been very fast. 2,000, 2,200, 2,400, 2,600. We're spinning between 2,000 and 3,000 revolutions per minute, and it takes a lot of energy. So it's that balance of a very light system, yet having enough energy that's needed to, spin the rotor so fast to lift, and on top of it, having to design in the autonomy.
It has to be fully autonomous from the time it takes off to the time it lands. What we do on the ground is we plan the flights, and so we determine from here where we want the helicopter to go.
Our experiment window is 30 Martian days. So we have planned up to 5 flights of incremental difficulty.
The very first flight, the main thing is we want to get the legs off the ground, and so we will basically go up about 3 meters, and we'll hover there, and then we'll come down again, and that will be the first, really major milestone.
Most of our flights will be at the 3 to 5 meter height. We will be going horizontally again at a few meters per second, probably go out, 50, 70 meters and come back. In successive flights, we'll probably push that further, try to go further. So our priority will be to get back engineering telemetry and not so much images, but I'm sure we'll return a few, because they'll always look cool.
At this point, we've tested all we can on Earth. We have mathematical models that shows how it'll fly at Mars, and we've tested it in the simulated environment that we can create on Earth. It really is time now to do the real flight test at Mars.
Nothing is a given, but we have done everything we can in terms of a test program here on Earth. The vehicle's performing extremely well so far. It's been doing exactly the right thing, even right now when it's bolted onto the Perseverance rover. So there's a very good chance that we'll pull it off, yes. But it's still high risk, and none of us forget that you could have a glitch that, could mean end of mission, yes.
It's going to be exciting, reacting to any surprises we have. We can't wait. What's really most important is everything we're learning here is for the future rotorcraft systems that we want to introduce into space exploration. To have built this Mars helicopter that's to the quality that's needed to be launched, to travel to Mars on board the Mars 2020 rover, and to have met the really stringent mass constraint, coming under 2 kilograms. In fact, we weighed in under 1.8 kilograms. We have to be light to fly at Mars. We built the Mars helicopter, the helicopter that'll go to Mars. And at this time, we've shown that it can fly. We've done the flight test in the chamber with the thin atmosphere representative of Mars. Very important. And secondly, we've tested it through the thermal environment. The environment at Mars, it gets very cold at night, down to like -°C. It's like temperature of dry ice. And we have cycled the temperature on this helicopter, the cycle, the extreme temperatures that it's going to see. And very importantly, we've shown that it can survive autonomously. We want to get to Mars. We're not done yet. The job is certainly not done yet. This is the test, the last test that we can do, the last flight test that we can do on Earth. But really our job isn't done until we see the same test flight being performed at Mars. So next time we fly, it'll be at Mars. But that's our ultimate goal. That's when we'll go, yes.
The Ingenuity Mars helicopter was designed to push the limits, and I'm going to show you how we've taken it to the extreme. Today, we're here in the Aerial Vehicles Lab at NASA's Jet Propulsion Laboratory, where we develop prototype helicopters. Ingenuity started off as a tech demo to push the aeronautical boundaries over the course of 5 flights. Then we transitioned into an operational demo phase where we partnered with the Perseverance rover to do science and scouting. But about a year ago, when the Perseverance rover started racing up the Jezero Crater Delta, we actually found that we had to work pretty hard to stay ahead of the rover. We decided it was time to shift gears again, once again pushing the boundaries of Martian flight. This campaign really began in earnest with Flight 49, where we simultaneously set new speed and altitude records. By Flight 62, we had nearly doubled our max speed and doubled our max altitude. We also tested different landing speeds, faster to save energy and slower to reduce landing loads. Both of these strategies may be used on future helicopters. We performed a type of flight testing called system identification. This is a crucial but risky procedure that helps us understand the vehicle's performance by how it responds. Our team also devised new ways to target the high-resolution camera, which allows us to provide advanced reconnaissance imaging for the rover. And we were able to take stunning shots like this one of Belva Crater from Flight 51. In addition, Ingenuity conducted several first-of-their-kind experiments on Martian wind and dust movement, which gave us new insight into the Martian atmosphere. What we've learned will help us design the next generation of Martian rotorcraft. We're testing more efficient blades. We're also working on a Mars science helicopter concept that could potentially transport heavier payloads and take us to more exciting locations on Mars. When people look back at Ingenuity, I really hope that they see how much this one small helicopter has done to elevate the limits of human achievement.